Hey folks, Quilly here, and welcome to another Unity tutorial on making our base building game, codename Project Porcupine. In the last episode, we implemented wall building, basically, so we can go and click and drag out some wall sections over here. You will get errors if you're building a wall across an area that already has one. That's fine. This is an error message we specifically put in here as a note of like, hey, you know you're trying to build something where you already got the wall, right? This is not actually some sort of bug in programming. We just have it in there for our purposes for clarity, and that's totally okay. So a couple of things. First of all, I want to I do intend to rename these installed objects to probably something like furniture. And I know that like most people won't think of walls and doors as furniture, which is fine. But and so a lot of people have brought up the idea of, hey, why not introduce some sort of subclass? Why not have windows and, or sorry, not windows, walls and doors be some sort of subclass or something like that? I'm intentionally trying to avoid introducing as many programming topics as possible. And in this case, I've made the decision that we can probably sidestep a lot of subclassing, derived class inheritance, that sort of thing. Hell, interfaces and whatever. Other than what we need, say, to interact with Unity, we're keeping that to a bare minimum. That's also one of the reasons I'm not going into details about the differentiation between, say, a private accessor and a protected one. We're sort of hand-waving that away at that point because that's going to be perfectly sufficient. And there's a lot of people who are still very new to programming, so we're trying to limit some of the introduced topics. But we are going to use lambdas because I like them, and I think in the end we will actually get a lot of benefit from that. And I don't think the subclassing will. I think people who are maybe still in university and learning, Java and object-oriented programming, I think people get very excited about subclassing very early on. But I think that for a lot of things, it's not going to help much. If we end up needing a lot of differentiation between doors, walls, and other furniture in code, then we will look into that in the future, and maybe a derived class is good. But for now, we're not going to worry about it. What we are going to worry about for now is changing the art of these walls, because one of the things is right now all the walls look the same, and really the graphics that we're using here are the ones that are designed for a wall that's basically on its own like this, right? But when you have a wall that's like this, a wall section, we really want these wall pieces to visually look connected. And in fact, that's exactly what we're going to be working on here, is purely the visual layer of our wall system. In code, our code doesn't really care if a wall is adjacent to one another. It doesn't distinguish one versus the other. But in terms of art, we have this sprite sheet over here. We have specific graphics that we're going to use for walls that are sort of corner pieces that meet in T-junction or maybe in the middle of this sort of plus thing. This one down here, we're going to ignore for now. We're not going to worry about this type of wall at this time. But all of these others, we want these walls to look like this in our game, as opposed to just a bunch of these in a line. So how are we going to progress with that? Well, at the end of the last episode, if I recall correctly, I ended up with sort of like, well, we sort of have to do a resources.load, and then I sort of trailed off because we're like, hold on, there's something I actually haven't done before. So let me explain what I mean by that. Let's go and close this off, and let's open up some code in our world controller here. Because right now our world controller has a direct reference to a wall sprite, and we're not going to do that. Well, I mean, we could in a sense, but right now it has a direct reference to a single sprite, which is the standalone wall sprite, the one that is not connected to any neighbors. And the reason I sort of trailed off is because, okay, normally, here's how you load things, right? So normally to get a reference to some sort of prefab, including things like sprites and sounds and those things, right? To get a reference to some sort of asset that's in your project, what you typically do in Unity is you have a public reference like this, and then you fill in the reference to that instance here in the inspector by simply clicking and dragging, which is what we did. We dragged our wall underscore sprite into this I don't know what you call this field in the inspector here, which is what's connecting us to this variable here, okay? And that's normally the way you do it. But, and we could get our wall system to use all the extra graphics simply by having more references, right? We've got the wall sprite. Well, we could have another one for the wall sprite that is connected to the east. So that's the sort of nomenclature we're going to use here. So that we could have a reference if we open up our sprite editor. And so a wall that's just connected directly to the east would be like this guy over here. So if I click and drag like that, so correctly check, it's a 32 by 30 to Sprite. There we go. Correct height. So we got all the pixels. And we want the pivot. I have decided that I'm going to have all my pivots be at the bottom left. There's nothing that would have stopped us from having it in the center, but I think it's going to simplify a little bit of our math later on. So we have the pivot in the bottom left, and there we go. And I'm going to call this wall underscore E to say this is a wall piece that's got a neighbor to the east and only to the east. So we apply this, and we've got it down here. So we've got wall underscore, wall ES. And if we go to the world controller, save. There it is. If we go to the world controller and let it recompile over here, I could drag a reference to this over here. And we could keep doing that. Now, we could get a little bit fancier if we used an array here, or even set up a special class to link the sprite data to like a string or something like that, and then made that all serializable. These are all words I'm basically just throwing out for people who have worked with Unity before and have thought of that as a solution. All of those things could work, but I feel like it would be awkward to continually have to do these links, to drag things into the inspector and make sure they're okay. Wouldn't it be easier if, so long as we named all of our sprites in a sensible manner, that the world controller could just automatically load these sprites? And you can indeed do that. So what you can't do is you can't just grab something from our project by name. There's no way for us to simply say, hey, load some prefab by name. We can't just do this. And the reason for this is, in Unity, when you actually compile your project to bundle out, any one of these objects here in your project folder that is not referenced by anything, if it's not on an object or linked from another prefab or referenced in something like this, Unity is actually smart enough to strip those things out of your project and not include them in your final exe because they're not referenced in any way. But as a result, you can't guarantee that something that you see in here can be accessed by some sort of function like that. Unless it's in a folder called resources. So if you create a folder called resources, like this, anything within this is going to be included in your build, in your executable file that you can distribute to people. Anything that's in here will be included, even if it's not referenced to anything. And as a result, Unity does provide a way for us to load assets from this folder at runtime. So, in other words, you don't have to link it in the inspector. You can have your code reference something that's in here, which is great. You can actually have multiple resource folders all over the place, and there can be subfolders within resources. It will all get bundled together in the end. And with that in mind, what I think we're going to do is I think I'm going to grab my images folder over here, and I'm just going to move it into resources. Like that. So why not? All these images should be included in our end project. We'll have to make sure we don't have extra copies of graphics or anything like this if we're looking to keep our executable tidy. But that's a problem. That's a problem for future us. For now, this is going to be awesome because now we can reference all these things in code. But, and here's the part where I sort of ran into an issue that I hadn't dealt with before. So the way you do this is you say resources.load. And there's a couple of different variants with this. Certainly, I like to use the version with generics. So you can do this. So load it as a type sprite, and then you give it some sort of name. You put in some sort of name. This is the path. And the path from here is going to be the path relative from the resources folder. So if we want to be able to load a wall bit, what we do is images/installed objects. Just because I haven't renamed the installed objects to furniture yet, I'm likely going to do that very soon. But let's wait a bit. So we're going to put another slash there. And then we reference the actual name of the prefab. But here's the problem I ran into. The name you would use is wall. This is the resource. It's called wall. You actually can't load wall underscore. And I'll show that. We're going to put in a debug. Debug.log loaded resource. And then we'll go, so we're going to store this. So this is going to be a sprite called S. We're going to store this here, and this is not going to work. Well, yeah, it's not going to work. So what we're going to do is we're going to debug, we're going to have this string, and then we're going to output this S. Okay, we're going to try to load wall underscore, which wall underscore is right here. All right, we have wall underscore. We've been referencing it over here. This clearly exists in some fashion, right? Actually, I guess I just realized something. I may know how to make this work. This will not work. There we go. See, no, loaded resources null. This sprite is null. This call here, this failed to load anything. On the other hand, if I left off the underscore, so images installed objects wall, right? Images installed objects wall, and we hit play, this will load something. It will load something called wall underscore, which makes no sense to me. This is referencing, so if we put in wall, instead of grabbing this, it's actually grabbing this for some reason. But how do we grab the others? Now I'm going to try something. I don't think this will work, but out of curiosity, if I went wall/wall e, because I actually hadn't tried this, right? If we do this, will this work? I don't think so, but it would be interesting if it did. No, it brought in a null. You see that? So you can't go images installed objects wall e. This doesn't work. So here's the problem. Great, so we can load wall underscore by referencing wall, but how do we get the wall e or wall es or any of the others? Instead of doing it this way, we're going to use something called load all. So with load all, you just pass it sort of a folder as the path. So images installed objects. And what this will do is it will load everything with a type of sprite and return it as an array, right? So we have an array of sprites now. And let's loop through this. So now we're going to have for each sprite s in sprites. Let me move this out of here. So we're going to loop through every single sprite in this array, and then we're just going to output a reference to it and see what that looks like. Let me bring up the console. Come on. There we are. Boom. Loaded resource, door EW, door NS, wall underscore, wall ES. Great. So if we do this, it will correctly find all of these subsprites. So we have a way to access them all. But what we can't do is pick a specific one. I can't say load this wall sprite right over here. I can't do that. But what I can do is get a list of all the sprites in this folder. So I think the solution for us in this case will be to make another dictionary, which is going to be a string, which is the name of the object, and a sprite. And maybe we'll call this, just to be consistent for now, I will call this installed object sprites. Okay, a dictionary like this. Again, we'll probably rename this to furniture sprites later on when we rename everything else. So now when we're loading the sprites, we're going to have to instantiate our new dictionary. There we go. We're going to have to instantiate our dictionary. Then we're going to run through all the sprites. And what we're going to do is we're going to go installed object sprites. We're going to grab s.name. This is the name of the sprite that we loaded with our resources.loadAll, and we're going to assign it to the sprite itself. So what we'll have now, and we'll just confirm that this runs, although it will run without an error, unless I've missed something. There we go. It runs just like before. We're just outputting the name of all the sprites. So now we have a dictionary here where we can just take a sprite name. So this dictionary will be full of things called wall underscore e, wall underscore es, and so on and so forth. So then we can grab the associated sprite at this point, which is great. So what we can do, obviously we don't need this wall sprite underscore e, but now we can also get rid of the wall sprite reference. Now, if we do this and we try to compile, I'm going to do that by hitting F8 over here. So it compiles in the editor, although if I just tabbed out, you get the errors here. You can see we got an error. The name wall sprite does not exist because, of course, I've removed the reference. There's nothing called wall sprite anymore. But we've got this spot. So instead, what we're going to do is say installed object sprites, and then in square brackets, we're going to pass it the string. Whoops, the string here. And for now, we're just going to go wall underscore. So we're going to set the sprite. So this is when we're creating the new object, the new game object in the game, the viewable game object, and it needs to know what sprite to show. So we're going to grab that sprite out of this array, and we're just going to grab the sprite called wall underscore. And I think that's literally the only reference to wall sprites that we had before. So now if we bring this down and we hit play, we should be back to our working code. So we're going to go build wall. I'm going to click. There it is, right? We are using that wall underscore sprite again, but we no longer have a direct reference to it. Instead, we're getting a list of every single sprite in this folder, putting it in dictionary, and then we can call it up whenever we want. Ooh, that's wonderful. And now that opens up the possibility of grabbing an alternate version of this graphic. So we can test that right away. Let's say instead of using wall E, wall underscore, let's use wall underscore E and see how that works. Wall underscore E. Okay, there we go. So now, oops, I gotta go to build wall. We're gonna click. There you go. You can see the version with that edge over there. If we drag it out, we're all using this wall underscore E variant. Excellent. Okay, we're in great shape now. Now, the thing we need to do, I'm just trying to shrink the view a little bit so we can fit it a little bit more by the width. I guess I should probably just unpin the document outline. There we go. That's probably a little bit better for people. Now what we need to do is a better system for finding the correct sprite for this wall, right? That's not actually that hard, but it's going to be a specialized function because there's only going to be a certain set of things that might care about its neighbors just for visual purposes, right? These are objects that sort of link together to form a bigger whole. Obviously, say, again, a sofa doesn't necessarily care if it's next to another sofa. It's not going to change its graphic. A table, well, I guess a table might. We might conceivably build some sort of system where you can sort of drag out your arbitrarily sized table. But in practice, I don't think that's going to happen. I think we might just have a particular size of table, and that's just the way it is, or maybe a couple of different variants of table. But there are a couple of things. If you think about something like RimWorld, for example, or Prison Architect, when you lay down power cables, it's, for example, in RimWorld, or the power cables or the water pipes in Prison Architect, the graphics there are aware of their neighbors because they sort of make bent corners or little plus signs, or they have a slightly different variant. And in particular, doors will also sort of care because the doors are going to want to be rendered in such a way that they look like they're attached to the neighboring walls, right? The doors, we sort of want them to auto-rotate in the right direction for the walls, which I don't think is something that happens in Prison Architect. I think in Prison Architect, you actually do have to rotate the doors to make sense on the walls. I don't remember exactly, although in RimWorld, you don't. The doors just auto-rotate to visually to make sense with the walls that are there. So we're going to want to do the same sort of thing. So what I'm going to suggest at this point is in our installed objects class over here, what if we just have a flag in here that says something like links to neighbor? Right? In a sense, this is the data layer here that's sort of coaching the visual layer, but I don't know if that's true. Like things that are linked to their neighbors, like power conduits, well, they actually are going to have a mechanical purpose for that because they're going to want to spread power to their neighbors, for example. Or maybe if temperature becomes a thing, for example, then we care about things being connected to their neighbors. Or maybe how fire spreads or something in the future. Like we can imagine situations where on the data layer, we actually do care if things are sort of linked to their neighbor as if they were a part of a whole object. And that's really what's happening with walls, right? With a wall that is linked to its neighbor, effectively, we're almost going to treat it like it's one solid object as opposed to a bunch of individual objects that are next to each other. So I'm going to suggest that we have some sort of, just maybe a Boolean called links to neighbor. I don't know if this is like the title I'm ultimately going to want to go with, but I think something like this is what we're looking for. And by default, it'll probably be false because most things, again, like sofas or whatever, won't really link to neighbors, but certain things might. And so this is just going to be, this might be used for some other data system, but it's also going to give a hint to our visual layer that, hey, you might want to render these a little bit differently, because they're supposed to be linked together. So, drop shadows and whatever might look a little bit different. Or even maybe the way you select these objects, right? You might be able to select them as a whole. This might also come into play very well with when we try to figure out what are rooms in our base, right? Self-enclosed rooms. So we're going to set that. And I guess we'll ask that this also gets passed in. So we'll accept a links to neighbor when we define this object, which will have default to false here too. That's perfectly fine. And then just grab it. So links to neighbor, links to neighbor. So this is where we create the prototype. And then when we actually place it, we're just going to want to make sure to copy that data from the prototype. There we go. So that is fine. Now, where do we... Is that just a visual glitch? Oh. Boolean. Now we're good? Now we're good. Okay. I forgot the little Boolean thing there. What was I going to say? Oh, yeah, where do we define our walls? I don't remember. So let's find a reference, create prototype. Oh, it happens in the world.cs, right? That's where we create our wall prototype. Again, later on, we're going to want to replace this with a much more sophisticated system that will probably read from data. But we're going to say that a wall, links to neighbors and sort of becomes part of a larger object. All right, so that's going to be a special thing that walls do. And this might be a good example of something that would work well as a subclass. You know, sometimes when you got a true-false flag like that that's going to influence behavior, that might be an excellent time to do a derived class. I'm just going to use it as a flag here and go with that. So when we place our object, I'm going to have, how are we going to work this? Well, the installed object has a name. Yes? Don't we? Object type, right. Object type. So really, it's the object type that determines the sprite we're going to use. In this case, the installed object's object type is literally just wall. W-A-L-L with a capital W is how we're implementing it, right? And we can see that here, wall. So let's make a function that returns a string. And this is something like sprite name. Or get sprite for installed object. So it's going to require an installed object. And what it's going to do, oh, it's not a string. It's going to return the correct sprite for this installed object. That's not exactly what I want, is it? That is not entirely what I want. I mean, so what I was going to do here is just say something like return installed object sprite and then obj.name. This is usually going to be correct. Installed object, is it protected? Oh, object type. It's not name, it's object type. Right, basically like this. Which is going to work for a lot of things. It's obviously not going to work for the wall. But basically, it's if obj dot, we can't reference linked, right? Links to neighbor because it is protected. So we want a public, we want to do the same thing we've been doing before. And there are other ways of doing this, but this is going to continue to be fine. It's going to be a public get, but it's going to be a protected set. So we can set this within our class or subclasses, and we can get it anywhere else. So now we should be able to say if object.links to neighbor equals false. And again, I'm not going to use that not thing. Then we just return this. This is the default is we just return the object type. We just return the object type from the sprite array. Done. But otherwise, the sprite name is more complicated. We're going to assume for now, we're just going to return the version which is the name plus the underscore. Okay? So now we're going to say here, instead of hardwiring in a particular wall, we're going to say get sprite for installed object, and we're going to pass it the object. So now if we run this, we should be back to the version that just puts down a single standalone wall. And we shouldn't have any errors. Oops, that's floor, so wall, there we go. We've got that. But this is being generated from this function here. And in the case of our wall, because our wall is set to links to neighbor, so links to neighbor is true, so it doesn't run this version, it runs this version that returns an underscore. If it returned here, we'd get a null sprite. There's no sprite in this array just called wall. We'd actually get an error. But instead we go here, wall underscore, that exists. So what we need to know is this sprite here, because it links to neighbor, we actually need to know if this thing is going to be in a spot where it has neighbors. So how are we going to check that? Well, I guess we have to feed this some coordinates. It has to know where the object is going to be installed, right? Int x, int y. So get sprite for installed objects needs to know the position of where this object will be installed to. Now, it doesn't care if it doesn't get linked to the neighbor. If it doesn't get linked to the neighbor, it doesn't care what the x and y is, period, done. But otherwise, what's going to happen, we're going to have a string, which is going to be the sprite name, like postfix or extension or appendices. The sprite name is going to be, well, I guess we'll just start like this. The sprite name is going to be the object plus object type, the object type plus the underscore. It's going to start with that. Okay, then we're going to return the sprite with that name. But then we got to check to see all the neighbors. And I think the order that I decided, we're going to check northeast, southwest. So check for neighbors north, east, southwest. That's right. North, east, southwest. We're just going clockwise round. So what we need to say is world. Actually, how do we get a world reference? World dot get tile at x, y minus 1. So this is going to be the tile to our north. Actually, sorry, I'm getting my directions wrong. A positive y is a tile to our north here. So the tile to our north, I guess we'll just have a placeholder. So something like tile t is equal to this. Or tile t is equal to this. If t not equals null, and t dot object dot installed object. Yeah, so we need to know if this has an installed object, which I don't think we have a way to get right now. Right? We have this installed object here, but we have no way to interact with it right now. And I guess, do we want to be able to just get a reference to it? I guess that's probably fine. So we'll do the same thing. We'll have public get protected set. So now back over here, we can get the tiles installed object dot object type, or make sure it's not null, right? Make sure that the installed object is not null, and finally make sure that the tiles installed object dot object type is equal to our current object dot object type. So if all those things are true, if there's a tile to our north and it has an installed object and the installed object type matches our object's type, then our sprite name is going to get an n applied to it. And then we're going to do the same thing for each other direction. So this is going to be east, south, and west. Obviously south is -1, and for east that's x plus 1, and for west it's x minus 1. So if it has a neighbor in every single side, what this is going to mean is by the time we get to here, for example, if this object has all 4 neighbors of the same type, then the string will look like wall underscore northeast southwest, like that. And it's going to return the right type of graphic. Now, we don't actually have all of these in here, but let's see if we can get this to work. I probably made about 13 different errors doing this. Not to mention, this may not be the most efficient implementation. We're going to find out. Oh, we're not feeding in the coordinates here yet, so we have to tell it the x and y. Do we not have that? Oh, this is on object create. Oh, right, the object at this point will know what tile it's in. Hold on, we don't have to pass that x and y, which is good, because it would make me feel really awkward passing this x and y. Instead, we can get that. Int x is going to be equal to our current object. So we can't get the x directly, but we know what tile we belong to, and the tile has an x. Same thing here with the y. So again, in something that doesn't link to its neighbors, we don't care what its position is. We just return the sprite that's got the same name as the object type. Done. But otherwise, we need to know what our current coordinates are. Then we need to check all of our neighbors. We've got to build a slightly more complicated string and then return the sprite that matches that. How are we looking now? Okay, let's give this a try. So we should be able to build wall, and I should be able to build a single one. Okay, that works. Great. and another single one, and another single one. Excellent. Now, we have sprites ready for a wall that is supposed to connect to the east, which means if I click here, we should have the version that doesn't have the shaded area on the right. Holy crap, it worked. I'm as surprised as you guys are. But we can very quickly, so we can keep doing this. It's the version without the version to the east. And obviously, it's not updating the rest of the blocks. That's okay. We'll sort that out after. So we've got that down. Great stuff. If I click down here, then the sprite that's going to be generated is a sprite that's got a neighbor to the north, right? So the string of the sprite it's going to try to load is going to be wall_n, which we don't have defined yet. So if I click this, I should get an error. Actually, I may not get an error. No, I will. And it's going to be because we get an error because it's trying to look up. It's right here. This will give you an error if there's no sprite in the dictionary with that name. What we could do is we could put a big if around here. We could check if installed object doesn't contain something with the name sprite name, then we could print a nicely printed error to the log and return null, and then we'd get an empty sprite. I guess that would be okay. I guess that would be more descriptive than this error. We get this and we're like, what's going on? Well, it's because you didn't create all your sprites, silly. So let's do that. If installed object sprites dot contains key of sprite name is false, okay? So if installed object sprites doesn't contain an item for this key, then we'll go debug.log error, and we'll say something like this. Have the function name. No sprite with name blah, or like this, like that, and the sprite name, like that. And then we'll just return null, which will be fine because it's going to assign a null sprite to our game object, which the game is perfectly fine with. Unity, if you assign a null sprite to a sprite field on a sprite render, it's okay. It just doesn't render anything. So now if we hit play, and I click here, and oops, go to wall mode, click here, and then build right underneath it, it should give us an error because there's nothing called wall_n. And that is true. There you go. So we get that error. Excellent. So now what we're going to do is I'm going to go through the sprite editor over here, and I'm going to create all those versions. So for example, right here, I think I need to go one lower, yeah, because the height should be 32 by 32. The pivot we want in the bottom left corner, and I'm going to call this, oh, this is actually wall_s. This is a wall with one neighbor to the south, right? And then I can grab, like, there's a bunch of different bits. This here and this here are both exactly the same. I just need to use one of them as an example of a wall that's only got one neighbor to the north. It's 32 by 32. We'll put the pivot to the bottom left, and we're going to call this wall_n. And then let's do another one here, a slightly more complicated example. So again, grab all this. It's 32 by 32. Excellent. This is a neighbor that's got a wall to the north, the east, and the south. And remember this order. It's always going to be NESW, and hopefully I haven't messed anything else. NESW. We're always going clockwise around here. So it's got that. So what I'm going to do is go through and create all the sprites for all the different connections over here. And then when we build any wall segment, the wall segment we build is going to look correct. It's not going to be quite done because what we're not doing yet, and we can actually test this right away. So now if I hit play and hit wall, put a standalone one. If I put one down here, this is going to be the version that's got a neighbor to the north. Indeed it is. You see there it doesn't have the shading to the north. Put it here. We've got a version for the south, so there's no shading to the south. Great. And we can keep going like that. But obviously it's not updating the neighbor. This neighbor here needs to be updated to the correct sprite to line everything up. So we're going to take care of that next time because this video has already gone well beyond 30 minutes. So next time what I'm going to do is continue to work on this code just a wee bit so that after we set up the sprite, we should go and tell the neighbors, hey, you might need to update your graphic. Just letting you know, you might need to update your graphic. And in particular, it could happen right here. There's no reason that right now we know we have a neighbor to our north that should be linked to us. So what we should do is tell it to update its graphic. We're going to take care of that next time. And I think the next time is also when we're going to go and rename installed objects to furniture, which isn't a particularly difficult thing to do, but is, we want to make sure we don't miss it, so I'll probably do it on screen with you guys. Thank you very much for watching. Thank you very much for continuing to support this series. Hopefully it's still useful to you. We'll see you next time, folks. Bye-bye. Thank you very much to all the November supporters over at patreon.com/quill18creates, and to these mic check level supporters. We've got Alex, we've got Wes Oldenbiving, we've got Andrew, we've got Craig Mortel, Philip Nichols, Neil Blakely Milner, we've got Speedy Savant, we've got Valiant Cake Fiend, Radel Del Peso, Aaron Toivson, maybe? Marius Fieldvold, Tim, Julian Auger Lafont, Stephen Stager, or Stagger, we've got Michael McClintock, and Bunny, and also everyone who's just watched, shared, favorited, subscribed these videos. You really make a massive difference when it comes to keeping the series going and making everything just interesting and awesome. And just thanks for watching and thanks for supporting. See you next time, folks.